Hello friends, it's Delta G. Welcome to my channel. If you've been keeping up with me, you know I've been working on the capacitive touch unit for the R4. I've learned a lot of new things, and now there's a full-fledged library called R4 Touch that you can use to create touch sensors on any pin that supports touch sensing. In this video, I'm going to show you around the new library. I'll start with a quick overview and show you some basic example code. Then I'll discuss a little bit about building and tuning the sensors. Now, building them is easy. Tuning is the challenging part. So I'll show you a piece of code at the end that you can use to auto-tune your sensors and quickly find the settings you need to make them work. Let's start by taking a look at the simple touch example from the library. This example shows you everything you need to get a single sensor going. Start by including the library r4touch.h. You can get it from the Library Manager in the IDE, or I'll leave a link to my GitHub page in the description. Create an instance of the touch sensor class and one of these CTSU pin settings structs for the settings. You need one for each sensor. I'll explain the settings a little more in the video. The auto-tune sketch is going to give you an output that you can copy-paste right into here, so it's going to be easy. Next is a variable for the threshold. The sensor counts are going to be compared to this threshold in order to determine the touch state. I'll talk more about the threshold when we get to the other settings, but the auto-tune sketch is also going to give you a suggested value for that. And finally, there's a variable for the pin number and a boolean that I'm going to use down in the loop function. In the setup function, we have to call begin on each sensor instance and pass in the pin number and the threshold value. Then we need this apply pin settings line to apply the settings. I'll probably fix it in the next update so you can just pass these settings directly to begin, but for right now, it just has to be a separate function. Finally, the last thing that has to be done in setup is to start the unit with touch sensor start. You only need this once no matter how many sensors you have. This will start things in a free running mode where as soon as one measurement cycle ends, it starts a new one, and the library always has up-to-date data. There's also a start single function that will run a single measurement if that's what you'd rather do. It does block, but touch measurements are really fast. Finally, down in loop, we use the read function to get the state of the sensor. This just returns a boolean, true if touched and otherwise false. You use it just like you would use digital read to read a regular button. If you're reading really fast and you have some noise in your sensor, you may even need the same type of debouncing code that you would use with a mechanical button. There's also a function called read raw that gets the raw sensor counts, and one called read reference that gets the reference counts if you want to use them directly for some advanced processing. The library works with any pin that supports touch sensing, and you can create as many sensors as there are pins to support them. Just call begin and apply settings for each one. The code uses direct transfer behind the scenes to avoid a bunch of interrupts firing. You do get the CTSU-FN interrupt at the end of the measurement cycle though, and the library has an attached callback function to attach a callback to that to be run before the cycle is restarted. You can use this if you want to try to catch every single reading or if you want to do some advanced processing or something. Now that's all the code you need, but in this state it probably won't result in a sensor that works very well or even at all. The problem is that there's a lot of variability in the size, shape, and electrical characteristics of each sensor, so there are a few settings that need to be tuned in order for the sensor to work properly. Now these settings are going to vary for each sensor based on the sensor design and the hardware you use, so let's talk a little bit about that hardware. I'm going to link a document from Renesas in the description that has a lot more information. The basic circuit looks like this. You'll need one capacitor, and then you'll also need one resistor for each sensor pad. The capacitor goes between the TS cap pin and ground. That's pin 10 on a minima and pin 7 on a Wi-Fi. The Renesas application recommends 10 nanofarads. Anything close to that's going to work. I've used 100 nanofarads and it seemed to work okay, although it seems the readings get less stable with the larger values. There also needs to be a damping resistor between each pad and the pin on the Arduino. Renesas recommends not less than 560 ohms and not more than 2000 ohms total resistance. I didn't have any 560s on hand, but a 1K resistor seems to work just great. The touch sensor itself is just a piece of metal. This can be a blob of solder, some metal foil, or a copper pad on a circuit board. You can experiment with lots of things. The particular material and the size and shape will affect the sensor's performance. You want to try to stick with round or squarish shapes and avoid any sharp angles. Don't try to make these S shapes like you see in most modern appliances. These sensors use mutual capacitance, which is something the R4 can do, but it's not implemented in the library yet. That's coming soon. The sensor needs to be covered by something. Touching the electrode directly risks sending ESD to the chip. The choice of material and its thickness will have a great effect on how well the sensor detects touches. Try to keep the covering thin and use a material with high electrical permittivity. The most important thing to think about is parasitic capacitance. The chip will measure capacitance change on the sensor, but it can only measure so much total capacitance. If the sensor is well isolated, then the capacitance between the pad and the finger is almost all of the capacitance being measured. But if there's a high parasitic capacitance between the sensor and the metal enclosure or a ground plane or a circuit board or anything else, then the capacitance to the finger is a much smaller part of what you're measuring, and it becomes much harder to tell when it's there. You also have to think about where your traces or wires run. These connections are essentially just extensions of the sensor, and they're also going to pick up the presence of a finger or anything else. So it's important to route these traces away from areas that will be touched or handled, or areas that are going to create a lot of parasitic capacitance. Now let's talk about the different tuning settings and what they do. The gain parameter is useful if the current is too large from the sensor. The current gain can be set to 100, 66, 50, or 40% using these settings. So far I haven't needed to set it to anything but 100%. I assume this comes into play for very large sensors. It will affect the accounts on both the sensor and the reference clock. The div setting sets the clock divider. It also affects both counts, and you should probably set this one first since it affects all the other settings. Values come from an enum, and the divider can be set to any even value from 2 to 64. Setting the clock divider is kind of a trade-off between speed and sensitivity. Shown here is a graph of the sensor counts from the love pin on my R4 minima in both touch states at all the various divider settings. You can see that at very low settings there isn't much difference between the touch states, but a gap quickly develops as the divider increases. Then beyond a point here, it seems to not make much difference. There is a setting for the reference current. This setting will only affect the reference count. It's mainly useful when tuning the sensor. Setting the reference current to the two extremes, 0 and 255, will show you the dynamic range of the ICO. When you're tuning your sensor, you should take note of these two extremes and see that your sensor readings stay between them. The reference ICO and the sensor ICO are supposed to have very similar responses across their linear range. So if you wanted to do some more advanced processing, you could probably set this to different values in between and build a sort of calibration curve between these arbitrary units and counts. The offset setting configures an offset current that's used to reduce the amount of current from the sensor. This one only affects the sensor counts. Now this is necessary since the ICO has a limited dynamic range and we don't want to spin that up measuring parasitic capacitance in the circuit. So we can offset the current such that we almost completely eliminate the current when not touched and leave the maximum amount of headroom for measuring touches. The count setting sets the number of measurements that will be added together each time you read the sensor. If you have a sensor that's a bit noisy, then taking more measurements can in effect average out that noise a little and give you a wider gap between the numbers for both states. Higher counts will give you more sensitive sensor up to the limit of ICO counts, but it also takes longer to read. Once you have all of these settings optimized, you can choose a threshold value that will give you a good discrimination between touch states. Now this all seems like a lot, and it took me a long time to get it figured out. So I wrote a sketch that does all these steps automatically. So this comes as an example with the library, and it's called autotune.ino. When you start it, it's going to ask you for the pin number. It's going to give you a list of options. You're going to make all your entries through the serial monitor. The A option runs the auto-tune procedure. It's going to run through a bunch of calculations. It'll stop periodically and ask you to accept something or modify it. Then it's going to ask you to touch the sensor a couple of times and do some tests, and it will spit out some results. At the end here, it outputs a setting struct and exactly the syntax you need to copy into your program, and also a suggested threshold value and some data on how well that threshold performs. Now it only handles one pin, so if you have more than one sensor, you have to reset the board and start over for each one. I'm not going to go into a lot of detail on how to use it because it'll probably see some big improvements in the near future, and I don't want the instructions here on the video to be wrong. The sketch outputs really good instructions on the serial monitor as it runs, and please feel free to ask any questions or make any suggestions if you think it can be improved. Hopefully that makes touch sensing simple enough that you can use it in whatever project you want with the R4. If you read on the Renesas application doc that I linked in the description, it describes even how to build sliders and jog wheels using these sensors, and that's definitely the kind of thing you could do using the read raw function instead of just using read. I can think of lots and lots of possible applications for these sensors and lots of things besides just touch sensing. So let me know in the comments if you think of something neat to build with touch sensors, and definitely if you build something cool, post me a link down here and let me see it. I want to see everything that you guys are building with anything that I've done here. Let me know if there's anything else in the Arduino world you'd like to see me hack. I'm always looking for new projects to play with. Definitely subscribe to the channel if you're into hacking Arduino controllers, because I plan to start sharing a lot of new things here. And if you have any questions or want to discuss the library, you can hit me in the comments or come find me on the Arduino forum at forum.arduino.cc. I'm Delta G. Until next time, happy hacking.